right, this is section 6 of chapter 6 or unit 6, and this is the fundamental theorem of calculus. You watched a video a second ago about the fundamental theorem of calculus, and this is a different part of it, and this is the super important part we're going to use all the time. So we have now done differential calculus and integral calculus, both of the two major branches. And we talked about this a little bit, but Leibniz and Newton independently discovered calculus, basically, and they independently discovered that there is a connection between the two branches. And the way we like to think about it, very informally, though, is that differentiation and integration are inverse operations. Okay, so that's important. So this is fundamental theorem of calculus part 1, which you would have just watched. So we're not going to talk about that again, but that's the derivative of the integral, and we get the displacement. This is the fundamental theorem of calculus part 2, and this is our big focus today. So this is what we also might call the evaluation theorem. So this is how you evaluate an integral. And we also call it a definite integral, okay? So a definite integral here because it has limits of integration. And so you would find the antiderivative, and then you would plug in b minus plugging in a. So that's basically how you do it. So easiest way to learn is really just to do examples and watch. Like a lot of things, very important to how you write your notation and being real careful. Now, I almost never use a straight line here. I usually use a bracket. So that's just how I'm going to do it because that's how I learned it. And because of some other reasons that you'll see. So that's just the way I'm always going to write it, but you may see just a straight line. So again, this will make a lot more sense as I do the problems. You'll start to see how to do that. Okay, so we're just going to do some examples. And you are going to make sure that you follow these examples very carefully in your notes and when you do your homework. So you want to write these in the same way and careful notation and be careful how you write things. Okay, so A says we need to integrate from 1 to 2 x squared minus 3 dx. Okay, so it's an expression, so I'm going to put an equal sign below so that I can do the work here. So first thing I need to do is find the antiderivative. So this is the last thing that we were practicing in the last section about just antiderivatives. So using your formulas, we need the antiderivative for x squared. So that would be to add 1 to the power and divide by the power. So that's x cubed over 3 minus, and the integral of 3 is just 3x. Then we're going to put a bracket here and we're going to say from 1 to 2. Okay, because that's the limits of integration. Do not switch the order. The order has to be the same as the order on the integral sign. Okay, so they have to be like that. And then we just do top minus bottom. So we're going to plug in the 2. So we're going to write 2 cubed over 3 minus 3 times 2. And then we're going to be really careful because we need to subtract plugging in 1. So we're going to write minus parentheses because we're going to have more than one term here. So we want to be sure that we don't mess up our sign and we forget and don't distribute it. So we plugged in 2 minus, now we plug in 1. So we'll have 1/3 minus 3. Okay? Then we would have an equal sign, again, keeping the equal signs lined up. I'm just going to start to simplify this a bit. So I'm going to have 8/3. Now, as you get better at it, you would have just already written 8/3. But the first few, you might have to do a couple of extra steps. That's okay. So I have 8/3 minus 6 minus 1/3 plus 3 because I need to distribute my minus. Now some hints. I have fractions and I have whole numbers or integers. You're going to add the fractions together, add the integers together, and then you'll combine and get a common denominator, okay? That's the worst thing you can do, is just sit here and decide, oh, they all need to be over 3. Nope. 8/3 minus 1/3 is 7/3. -6 plus 3 is -3. And now the problem's really easy because 3 would be 9/3. So 7/3 minus 9/3, -2/3. Okay, so that's the answer for the integral from 1 to 2 of x squared minus 3. Now the answer is negative. So a lot of times students get real freaked out about that. They're like, wait, but integration's area and it can't be negative. But remember that integration is not area. It's only area if the entire function is above the x-axis. Well, we know this function is a parabola that opens up and has been shifted down 3. So from 1 to 2, we are probably all the way under the x-axis, and so negative totally makes sense. Okay? All right, so let's move to B here. So first thing I'm going to do is I'm going to rewrite this because it is not in the format that I want for doing an integral. I need to change this to a power. And that's stuff that we've been practicing, so hopefully that's starting to get easy. Now the problem's really easy. I need the antiderivative. So I'm going to put the 3 here and then a bracket. So remember, we can pull the constants in front and leave it alone. Now I'm going to do x to the 1/2, and I'm going to find the antiderivative. So I'm going to leave a little space, and I'm going to write x, and I'm going to add 1 to the power. So 1/2 plus 2 over 2, that's 3 over 2. And then remember, instead of dividing by 3/2, I do times 2/3. Okay, and then I'm evaluating that from 1 to 4. Now, before I evaluate it, I could simplify it a little bit, or here's actually what I do. The constant part can move all the way out front. So 3 times 2/3 is going to be 2. So I'm going to put it out in front and then have a bracket. Now the thing I have to remember is I took this and I multiplied it by the 3, so it's not there anymore. Now I'm just going to plug in 4 to the 3/2 minus 1 to the 3/2. Okay, so I really strongly suggest you learn to do this with your constants, because if you'll pull them out front, you don't have to keep multiplying them and dealing with fractions and all that kind of stuff. I just have a 2 out in front instead of it being 2/3, 4 to the 3/2 minus 2/3, etc. Okay, so it's much easier if you'll pull those constants out in front. So this is the kind of stuff that you need to practice heavily when you do your homework. So I'm going to leave the 2 alone. I'm going to simplify inside. So 4 to the 3/2. We remember we do the root first. So square root of 4 is 2. 2 cubed is 8. 1 to the 3/2, of course, is just 1. So my final answer here is 14. Okay, now I did a lot of extra steps on some of this arithmetic. You may not need to do quite as many steps. The key is, if you start making mistakes, you're probably cutting too many things out, especially sign errors and things like that. So use caution if you're going to do that. Okay, so now let's do C. So C, again, the first thing I need to do is find the antiderivative. Well, at this moment, we don't know how to do 2x minus 1 whole thing squared. We don't have a formula for that. The formulas that we have are for powers. Okay, so the first thing I'm going to have to do is not any integration yet. I'm just going to have to multiply this out so that I can do the antiderivatives. So I'm just going to square that binomial, which of course has 3 terms. Now I'm going to do the antiderivative. So I'm going to have 4, and then it'll be x cubed over 3 minus, now when I look at the 4x, hopefully I can realize that's just 2x squared when I do the antiderivative, because I'm thinking backwards. So the derivative of negative 2x squared would be negative 4x, and then I have plus x, and then I need my bracket, -1 to 1. So now I'm going to plug in the 1, and then I'm going to minus parentheses plugging in the -1, okay? So plugging in 1, I'll have 4/3 minus 2 plus 1 minus parentheses. Now plug in -1. So -1 cubed will give me -1. So this will be -4/3. -1 squared is 1. So times -2, still -2. And then minus 1. Now here's again the part where you got to be careful and be smart. Combine the things that go together and leave the other stuff for a minute. So I'm going to do 4/3, and then remember it's minus -4/3. So that's 4/3 plus 4/3, that's 8/3. Then I have -2 plus 1 is -1 minus -3, because inside here is -3, but don't forget it's minus. So I have -1 minus -3, that's plus 2, because that's -1 plus, it's a minus 3, so it's -1 plus 3, so that's plus 2. Now the fraction and the number are easy. 2 is 6/3, so 6/3 and 18/3, or 8/3 is 14/3. Okay, so please listen to my hint about adding all your fractional stuff together that all have common denominators. Get all that combined, all your integers added together, then combine stuff, okay? Because it's going to happen a lot, so please listen to that. Okay, so next problem on D. So again, first thing I do is I want to do the antiderivative of the inside. I don't need to rewrite here, I already can do this. So the antiderivative for sine would be minus cosine x, because I have to think to myself, what do I take the derivative of that would give me sine x? Well, the derivative of cosine would be minus sine. So therefore, I've got to put a negative in front to get rid of that negative, okay? Plus x, and then again, I'm going from 0 to pi. So I'm going to plug in. So I'm going to write minus cosine pi plus pi minus parentheses minus cosine of 0 plus 0. And be careful, because a lot of times students want to just subtract 0. They're plugging in 0, so they think everything just becomes 0. But for example, cosine of 0 is not 0, so be careful about that. So I have a minus a cosine of pi. Cosine of pi is -1, so minus -1 is 1, plus pi. Then I have minus negative cosine 0. Cosine of 0 is 1, so minus -1 would be plus 1, and then minus 0, so I don't need to write that, so I get 2 plus pi for my answer. And I do want you to simplify every single one of these. Obviously, on a free response question, you would stop, but you have to practice all these skills with adding fractions and dealing with stuff. So you are going to simplify all of these until they can't add together anything else, okay? Till you've done common denominators, like terms, all that kind of stuff. Okay, so let's look at E. So we know that the first thing we need to do is the antiderivative. Well, I'm going to have to do some rewriting because, again, I have no formula for square root, so I don't know how to do this, but I do know how to do powers, okay? So we're going to rewrite this. It's going to take me 2 steps. So I recognize that this is square root of 2 over square root of x dx, because when you are square rooting fractions, you can square root the top, square root the bottom, as long as they're both positive, which we're from 1 to 8, so we're good. So one more step. Square root of 2 is just a number. It's going to stay there, but I'm going to want x to be brought to the top and have a power. So since it's a positive 1/2 power in the bottom, it's a negative 1/2 to bring it to the top. Okay? Now we're going to do our process. We've got to do the antiderivative. So none of this, notice the integral signs are all still written because we didn't do any antiderivatives yet. All we did was rewrite it so that we could. So I prefer to put, again, square root of 2 out in front, then put a bracket. Then I'm going to do my x to the negative 1/2. That would be x to the positive 1/2, because we add 1 times 2, because it's times the reciprocal of the power. And then I'm going from 1 to 8. So I'm going to write the 2 square root of 2 out in front. So this whole thing I just pulled out in front. And then that way I don't have to deal with it. I just do 8 to the 1/2 minus 1 to the 1/2, which is just going to be 1. So now you need to recognize that 8 to the 1/2 just means square root of 8. Square root of 8 times square root of 2 would be square root of 16, which is 4. So I'm going to get 8 for that first product. And then, so that was this product. And then 2 square root of 2 times minus 1, of course, would just be negative 2 square root of 2. So therefore, that is my answer, 8 minus 2 square root of 2. Okay, let's go to F. So this is one that some people had questions on homework about how to do that. So again, you have to remember, there's no quotient rule for integration, so we cannot integrate a quotient unless it's a formula that just is a quotient that we have an exact formula for, or we have to rewrite it because we have no quotient rule and we have no product rule. So if you have a quotient or a product, if it's not an exact formula, then we have to rewrite it. So this one will need to be rewritten by taking this square root of x, which is x to the 1/2, and you're going to divide each thing in the top by that x to the 1/2. So we have x to the first in the top, x to the 1/2 in the bottom. That will make an x to the 1/2 in the top. Then you'll have minus 2x to the negative 1/2, because I can't do anything with that, dx. Okay, because all I can do is move the x to the negative 1/2 up with the 2. And that's my rewritten problem that I now can do because I have a formula for powers. Okay, so we are going to start doing these. So I have x, and it's currently to the 1/2. So I add 1, which is 2 over 2. So I get 3 over 2. And then I multiply by the reciprocal of the power when it's a fraction. Okay, minus, I have a 2 already here. I'm going to leave a little space, and I'm going to have x to the positive 1/2 divide by 1/2, which is times 2. And then I am going from 1 to 4. Okay, so this time the constants are not the same for each one, so I'm just going to leave the constants tagging along because I really can't make that any easier. So I'm just going to write it as I plug it in. So I have 2/3 times 4 to the 3/2 minus, now I will go ahead and write that as 4, and then I'll have, I'm plugging in 4 to the 1/2 minus parentheses 2/3 times 1 to the 3/2, but of course 1 raised to a power is still 1, minus 4 times, again, 1 to the 1/2, which is still 1. So before I can figure out my fractions, I'm going to have to simplify my fractional exponents, and then I'll combine the things that can go together. So I have 4 to the 3/2. So of course we do the root first. So we have square root of 4 is 2. 2 cubed is 8. That makes this 16/3 minus square root of 4. So 4 to the 1/2. Square root of 4 is 2 times the 4. That's minus 8. Minus 2/3 plus 4 by distributing that minus sign. And then I'm going to, again, combine the two things that both have the same denominator. So 16/3 minus 2/3 is 14/3. Negative 8 plus 4 is minus 4. And now, again, it's super easy because I just have my fraction, 14/3 minus 4. 4 in thirds would be 12 thirds. So 14 thirds minus 12 thirds is 2 thirds. So again, strongly suggest you work really hard at all of those fractional fractions that you add and subtract and so on. Okay, so that's actually all we're going to do in this video. The rest of the notes we're going to do in class and talk about it to finish that up. And so this completes the second half, the second video for your videos.